This is the last of the BC topics. This is polar graphing, and we had two formulas that are used a lot, in particular in this one. One is that the area is 1/2 alpha to beta r squared d theta. That's the area. The slope dy dx is just dy d theta over dx d theta. Now what's tricky about this, though, is that x itself is r times the cosine of theta. And sometimes we'll have a hidey-ho when we take that dx d theta, as we'll see. And then the y is r sine theta, same thing. We might have to do, for this dy d theta, we might have to do a hi-ho with this. And we will this today. All right, so for number 3, it says the graph of the two polars r equal 2. So this is the origin, center, and r equal to 2 is just this first circle. Then r equal to 3 minus 2 cosine is this sideways cardioid shape. Now, what do you notice? This is 3 plus 2 cosine, correct? What do you think we would do to turn this into a heart-shaped cardioid so it's vertical? Change what? 3 plus 2 cosine theta into 3 plus 2 what? Sine theta. That'll rotate at 90 degrees. And that's what you'll see on your old honors pre-calc Valentine. All right, so what we're going to do next is we're going to go from theta is 2 pi over 3, 4 pi over 3. They were super generous. I've never seen this before, but they would tell you where these intersections are, 4 pi over 3 and 2 pi over 3. That's all right. You are supposed to figure out what the area is of that shaded region. So what some people do, the area of R, is they figure out the area of this Pac-Man shape, this circle. Now the area of a circle is pi r squared. What's the radius of this circle? 2. Okay. And what fraction of a circle is it if we have the intersections at 2 pi over 3 to 4 pi over 3? What fraction of the circle is it? This looks like it's perfect 2/3, isn't it? 2/3 of that. So that's the area of the Pac-Man shape. Now all we have left is the area of this part. And what's nice about this is it is a series of sectors. So we have the 1/2 going from low 2 pi over 3 to 4 pi over 3. Still have that. And then all we need to know is the radius. And what's the radius that we put into this green part? What's the radius of that? The formula, 3 plus 2 cosine theta, d theta. Don't forget to square it, right? And that's the area of that region. You have the 2/3 of a triangle, or of a circle, excuse me, plus this area, which you would use calculus to find. That's part A. I think you have to figure it out, though, with your calculator to actually calculate it. This is no problem. This is 8 pi over 3. And then this you'd use your calculator to find. Yeah. Any other questions? So now for part B. It says a particle moving with a non-zero velocity along the polar graph of r equals has a position vector of x of t, y of t at time t. The particle moves along the curve in such a way that dr dt is the same as dr d theta. All they're saying is that when you find dr d theta, you're finding dr dt. That's to help make things a little simpler. So in part B, it says, particle moves, find the value of dr dt. So in part B, find dr dt. Well, that's the same as dr d theta. And so we just take the derivative of this. Derivative of 3 is 0. Derivative of -2 cosine, negative sine theta. That's it. That's it. And then it says interpret your answer in terms of the motion of the particle. So it says this particle moves along the curve, find the value of dr dt at theta equals. So when theta is equal to pi over 3, dr d theta is equal to 2 times the sine of pi over 3. And I think that's just, isn't that just square root of 3 over 2, right? So it's the square root of 3. And where did I lose my negative? Oh, I know what I did. So when I was reading this, this should be 3 plus 2 cosine theta. I thought it was a minus. So this is going to still be negative. This will be a negative. So negative square root of 3. So what we would do for your answer is what it's saying here, and that's, by the way, negative square root of 3. The particle is moving closer to the origin. Instead of going out, positive, it's going in. So we would say it's moving toward the origin. So negative means toward the origin. So what you would write would be, since dr dt is less than 0, the particle moves the origin toward or away. It's negative, so it moves toward. Help me, grammarians. Toward or toward? Toward? I don't know. You could go all day on that. And then for the particle described, find dy dt and interpret that one. So with this one, you're just going to find dy dt, which is equal to dy d theta. So this is going to be, remember y is r sine theta. So you're going to have a hidey-ho. Hi is 3 plus 2 cosine theta. Derivative of sine is cosine. Okay, plus sine theta, ho, d high is negative 2 sine theta. Okay, and then you put in theta equals pi over 3. Plug those in, you'll get an answer. And just to save time, the answer turns out to be 0.5, positive 0.5, which means in the y direction, it's moving away from the x-axis. So here's the x-axis. If it's positive dy d theta, positive, or dy dt, I guess you'd say, then it's moving away from the x. So they would say away from the x-axis. And they're looking for this as a point for the marks in AP. So that's what they mean by interpretation. You got to show what the rate is, greater than or less than 0, and what it means, moving away from the x-axis. And that is that polar problem. Question arose about the one of the multiple choice problems, number 86. It says here that the slope dy dx is twice of x. Okay? If f of 2 equals 3, what's the value of f of 3? Okay, so if f of 2 is equal to 3, what's the value of f of 3? Okay, so if you took the derivative of this, dy dx, you're going to get the y value, right? Or, excuse me. Y is going to be the value, and that's equal to, in this case, 3. See that? Okay. So y is equal to 3, and then it says the slope at any point is twice the value of that. So what is the value of f of 3? So what they're saying is if you took the antiderivative of the slope, 2x, you're going to get the y value. So we're going to take the antiderivative of this and get x squared plus c, okay? And then this is going to be equal to y, all right? So if that's the case, y equal x squared plus c, we need to know what c is. So that's where this point comes in, 2, 3. X is 2, y is 3. So you get 3 minus 4 equals c. c is negative 1. So now I have y equals x squared minus 1, and then put a 3 in for x. And what's y going to be? I think it's 8. Did it work? Is that right? Yeah. Good. So the key there was recognizing that the slope equal to 2x, we take the antiderivative to get the y. Any other ones on that set? How about the, yeah. Previous one. Okay. And 85, a particle moves in this direction of this velocity. How many times does the particle change direction? So you have v of t equals 3t to the fourth minus 11t squared. Do you agree with that? Plus 9t minus 2. Okay, they're saying particle moves velocity given by. How many times does the particle change direction as t increases from negative 3 to 3? So what is going to designate a change in direction? Yeah. V of t equals 0. So what you're going to do is you're going to graph this between negative 3 and 3 and see how many zeros you have. Oh, really? Are you sure you got all the answers? Sometimes their graphs are tricky. Was it answer 2? Yeah, because there's a bounce in there. So one of them is going to do this. You know, so it's still only 2 changing directions. Good. You okay with the other ones? Yeah, Mark. 83. Okay. So 83 is one that you're going to use a calculator for. Whenever I didn't tell you which ones to use the calculator, it'll be very clear on the BC test. But if you see all these decimals, obviously you need a calculator for that. So what you're going to do first is you're going to find intersections. And this is a cube. So there's probably going to be, when you draw a line through it, I would guess there'll be 3 intersections. x1, x2, x3. That's my guess. So if you just integrated from the low to the high, you're going to get this area canceling out of some of that. So you're going to need to integrate this one, y1 minus y2. You're going to take one minus the other one, and you're going to go from x1 to x2. Then you're going to do another one, I should say 2 minus y1. Doesn't matter the order, as you're going to see, dx. And then you're going to go from x2 to x3. And then what happens is take the absolute value of these and add them up to get that area between. You better believe that these smaller ones are not splitting them up. It's going to be from low to high. So you want to make sure you split them up and add them. And I don't remember which answer it is, but is that okay? Can you do that with your calculator? So what you could do is you have x to the third minus 8x squared plus 18x minus 5. Then you're going to subtract x plus 5. So what you would put in your formula would probably be x cubed minus 8x squared plus 18x minus 1 is 17x. Negative 5 minus 5 is negative 10. That's what you would put in for this. And then you just integrate that with your calculator. Everybody's okay with that? Function, comma, x, comma, low, comma, high. But you got to find those intersections first.